Hello students, today we are going to take up the topic P block elements group 15 part number 1. Under that we are going to discuss about general characteristic of group 15 elements. This is the first video on group 15 element. So let us start with a very good thought. Be happy with what you have. Be excited about what you want. Alan Cohen. So point is that whatever we possess, we should be happy. We have to have contentment, the thinking of contentment in your mind, so that we can live happily with our present circumstances. Okay, so learning outcomes from this session is students will be able to explain about general introduction occurrence of nitrogen, general characteristic of group 15 elements in regard to electronic configuration, oxidation states, and some trends in physical properties like melting point, boiling point, density, ionization energy, electron affinity, electronegativity, and metallic character. Okay, let us start. We are going to start the discussion in group 15 elements. So what you have to do? First, you have to remember the first group 15 elements: nitrogen, phosphorus, arsenic, antimony, bismuth. This way, these three and 2, this you have to remember: nitrogen, phosphorus, arsenic, antimony, bismuth. When you repeat 3 or 5 times, it will be in your tips. So okay, nitrogen, phosphorus, arsenic, antimony, bismuth. Fine. 7 plus 8, 15. 15 plus 18, 33, and then again 18, and then 32. So this way we can remember the atomic number also. So here is the symbols: nitrogen P, nitrogen and phosphorus P, arsenic AS, antimony SB, bismuth BI. Arsenic, antimony, bismuth, these are poisons basically for the catalyst. We have discussed in the chapters of chemistry. Okay, so let us start with the occurrence. Occurrence means how it is available in the nature or in the crust. So nitrogen as such free state, you know that here it is present 78% by volume. Okay, and in combined state, nitrogen is available in the form like salts, like child saltpeter, NaNO3. Similarly, Indian saltpeter, KNO3, means nitrates, sodium and potassium nitrates. So then again we are having ammonium sulfates. So sulfates, rocks are there. So these are basically the components of rocks and minerals. Now phosphorus, this nitrogen is the first element, next comes to phosphorus. It does not occur in free state because it is very reactive. If you remember the red phosphorus, white phosphorus is highly reactive. The red phosphorus is little bit less reactive because of polymeric structure, and moreover you should know about the mastic, whatever the component is there which we are burning, we are just with the friction starts burning, that is red phosphorus. Okay, so phosphorite, Ca3PO4 twice, fluoropatite, Ca3PO4 twice, CaF2, chloropatite, Ca3 phosphate, calcium. We need not to remember this formulas and all that. We here are explaining that it exists as phosphates in the occurrence in the nature, although they may not ask anything regarding to that. Similarly, ADP, ATP, these are the very important components of nucleic acids. So that is deciding the hereditary characteristics, and the phosphate is there. So phosphorus, the elements, the use of elements, the availability in nature, that we are explaining now. Arsenic, antimony, bismuths are not much abundant. Okay, so let us discuss the first characteristic: general electronic configuration of group 15 element. General is NS2NP3. It means nitrogen, it is 2s2 2p3, phosphorus 3s2 3p3, arsenic 4s2 4p3, outermost shell, second shell, third shell, fourth shell, similarly period, second period, third period, fourth period, fifth period, and sixth period. Seventh, why we are not considering? Because it comes under D block and F block elements, so therefore we are not considering that. But basically our structure for P is here this manner. Last electron enters the P orbital, therefore P block elements. So period is clear to you, group number is clear to you. Group number how to calculate? The 10 plus the number of valence electron. Valence electron is not only 2p3, it is 2s2 2p3. So total 5 would be there. 10 plus 5, 15, and the group number is same in a group. Okay. Okay, so nitrogen, phosphorus, arsenic, antimony, bismuth. Atomic number we are clear with, group number we are clear with, period number we are clear with, and we are clear with electronic configuration as well. Okay, so here what is the important thing you are discussing here in the period number 4? You are seeing that d orbitals are being filled. Okay, so this is the important thing we need to remember, and it will be used. And in the last, if you see, 4f filling is starting. 4f and 5d. So these are known as inner orbitals. Okay, electronic configuration, as you have seen previously, that normally if 2 electrons are lost from this 2s2 and 3 electrons are lost from 2p3, means to say that if 5 electrons are lost from the outermost shell, the electronic config means the oxidation state, the tendency to lose 5 electrons, it will be plus 5. It can be 3 electron can be lost from 2p3, so plus 3. Now the chance is that they are having 5 valence electron. If they are gaining 3 electron, so then also the octet is completed, either by losing electron or gaining electron. If gaining of electron takes place, so minus 3 is the oxidation state. So this is only the difference between the oxidation state and valency. Oxidation state will be that along with the charge, negative or positive, but valency is always having no charge as such. Stability of plus 5 oxidation state decreases as we move down the group due to inert pair effect. So what basically is inert pair effect? We can discuss now. Okay, so here if you see the inert pair effect, let us see first, we can discuss this. Reluctance of ns2 electrons to take part in bonding due to poor shielding effect of intervening d and f orbitals, means inner orbitals d and f, n-1, n-2, and on the moving down the group is known as inert pair effect. It means to say that because this inner d and f orbitals are having poor shielding effect. Shielding means it shields less from of the outermost valence electron towards the nucleus. So means the force of attraction is increased due to the presence of these poor shielded orbitals. So now what is going to happen is, the earlier we were having ns2 np3 electrons in the valence shell, ns2 np3. Now the point is that these two, ns2, which is very close to the nucleus, it will not be lost. So how many electrons can be removed is 2p3. So 2p3 only electrons if it is lost, so then oxidation state will be plus 3 only, not plus 5. This is the reason why plus 5 oxidation state decreases as we move down the group due to inert pair effect. Whenever the question is coming, you have to write the due to inert pair effect, and then you have to explain the inert pair effect. Okay, so please listen to the previous video on that. That is video number 4, basic concept of inorganic chemistry, if you want to understand more for inert pair effect. Okay, physical state. Physical state, as you know, the nitrogen is gas, phosphorus is a vaporizable solid, arsenic is solid, antimony solids. So as we see, the gas and solid nature depends on the melting point. Melting point increases down the group. So is the case for boiling point also. So it depends on the forces, the force of interactions in between the atoms. So now as you see from here, nitrogen is gas, phosphorus is a solid, arsenic solids are here, and here you can see the atomic radius, density also. Density is increasing, see 1.14, 1.82, 5.75, 6.6. So density what? Mass by volume. Mass means nuclear charge, volume. So increase in mass is more as compared to volume, therefore density will increase. Similarly, melting point, if you see here, 63,317 and 904577, here also the same question can be asked. So why bismuth is having the lower melting point? So there again the point is same only. So earlier there was having tendency to plus 5 oxidation state, 5 covalent bonds can be formed. Here it is 3 covalent bonds will be formed. So therefore if 3 covalent bonds will be there, interactions would be weak, thereby melting point will be less. Okay, so this is all based on concepts. Let us see the atomic radius. Atomic radius increases down the group. Okay, and similarly the density we have discussed already, it increases, melting point also increases, but certain changes here in the bismuth. Okay, so now atomic and ionic. Atomic means N ionic means N3 negative. So atomic and ionic radii increases down the group. There is an appreciable increase in covalent radii from nitrogen to phosphorus. You can see from here, so nitrogen atomic radius is 1.55, 1.88, 1.80, 1.85, 2.06, 2.07. So here the variation is there, the atomic radius down the group increases. There is small increase from arsenic to bismuth, the reason being the same. There is the filling of d or f orbital which is having poor shielding fact, which leads to decrease in the size little bit. Although it is increased compared to nitrogen, phosphorus, arsenic, but relatively it increases less. So now here the same thing, atomic radius 70, nitrogen, and if you talk of boron belongs to group 13 to 14 it decreases, means group 14, group 15 elements are having lesser atomic size as compared to group 13. Okay, in a period atomic radii decrease, that is the meaning. And arsenic to bismuth, there is only small increase in radius because of imperfect or ineffective shielding of due to filling of d or f orbitals. These are also known as inner orbitals. Okay, and let us discuss the word. This is also known as nitrogens. Nitrogen means, that is, we have derived it from Greek word nigene. Nigene means to choke. Sometimes we heavily coughing. So that choking type of behavior or physical state occurs when the inhalation of these gases takes place, and it is also related with some poison I have already discussed with you. So this arsenic, antimony, bismuth, these are poisons basically for the catalyst, and moreover nitrogen as such it will be choking because it does not help in the, we are not breathing nitrogen, we are breathing only oxygen. If only nitrogen is there in the atmosphere, we will feel difficult to breathe. That's the meaning of choking. What do we know about the group 15 element? That we have discussed already. Nitrogen and phosphorus is non-metal, and down the group metallic character increases because tendency to lose electron increases. Why? Because low ionization energy, means down the group ionization energy decreases. Why decreases? Because atomic size increases. So we have discussed already the questions regarding to 3 plus and why it is down the group plus 3 oxidation state is more stable as compared to plus 5 due to inert pair fact we have discussed. And so further we can see the density, all the states and all that, all these points we have discussed in detail. Now the melting point, boiling point, as we have discussed already, this lower melting point of bismuth is due to tendency to form 3 covalent bonds instead of 5. This is due to inert pair fact. Okay. Now this already we discussed about inert pair fact. So same case, plus 3 oxidation state is more stable than plus 5. Why? The question answer is same, the inert pair fact. Then we have to explain about the inert pair. Next property is ionization energy or ionization enthalpy. What is ionization energy? It's a tendency of an element. So it is the amount of energy required to remove an electron from isolated neutral gaseous atom to form positive ion. For example, phosphorus is there, nitrogen is there. What amount of energy is required to make it N plus, or what amount of energy is required to make P plus? So 1 electron is lost. If 2 plus 2 and then phosphorus 3 plus, this manner. So normally, as the size is more, ionization energy would be less, and as the size is less, ionization energy would be more. So we can say that decreases down the group. Why? Because atomic size is increasing. And nuclear pull, then some people will say, sir, nuclear pull also increases. Yes, of course, but the nuclear pull as compared to atomic size is more predominant as compared to nuclear size, thereby the ionization energy is decreasing, because ionization energy is not only in one factor derived, it is derived from the number of factors like ionization energy, atomic size and nuclear charge and screening cost and imperfect shielding and how close is the sp-d-f orbital towards the nucleus. Next is in the group, if you compare 14 and 15, you know 15 is having lesser atomic size, therefore ionization energy would be more. Then we can say that in period the ionization energy increases. Why? Because relative nuclear charge is increasing. Because here we cannot say that the number of shells being added. No, number of shells remains same, and therefore the atomic size is decreasing and nuclear charge is increasing. That's why we can say that ionization energy of group 15 elements are more than that of group 14 elements. So these are the certain properties ionization energy we can see from here. 1402 and down it is decreasing. This is the point to understand. Similarly, electronegativities also, it's having a decreasing trend. Okay, and these are the properties we have discussed in detail already. So now let's come to the electronegativity. It is the tendency of an element to attract the shared pair of electron towards itself. Shared pair, bonding is there, bonded. So for example, PCl3 is there, P and chlorine, which is having more electronegativity. Of course, chlorine. Chlorine will try to attract the electron, the shared electron. So phosphorus will be having small positive charge, chlorine will be having small negative charge. That leads to polarity, the polar covalent bonds. So group 15 elements having more electronegativity than group 14. As we know, the atomic size is decreasing, and as we move from left to right, the electronegativity is increasing. Okay, and electronegativity is decreasing down the group. Why? Because the atomic size is increasing down the group. And moreover, metallic character is increasing. Metal means electropositive character. Electropositive character increases down the group. Therefore, electronegativity decreases down the group. So all the fundamentals, interrelated fundamentals should be clear to you. Okay. So you can see from here, the nitrogen family is having more electronegativity as compared to group 14. But 16 group is more than 15 and 17 group is more than 16. Okay. Now this is metallic character. As we discussed already, nitrogen is non-metal, phosphorus is non-metal, arsenic is a metal, so antimony is a metalloid, and bismuth is a metal. Okay, so here we can see that here I might be also metalloid. We have to check that. Okay, elements of group 15 are less metallic than group 14 elements. Reason is higher nuclear charge. Because more is the nuclear charge, more will be the force of attraction between the nucleus and the valence electron. The electron will find difficult to move out. Therefore, ionization energy will be high. If ionization energy is high, the metallic character will be less. If metallic is less, it means non-metallic. Okay. Similarly, when moving down the group, what happens? The atomic size is increasing and the ionization energy is decreasing. The tendency to lose electron will be more. Therefore, ionization energy will be less, and that will be more electropositive, that will be more metallic. So down the group, metallic character increases. That's why I told you that arsenic also comes under the metalloid or non-metal. Fine. Okay. So now the next point is oxidation state. We have discussed about already that this point that +5 oxidation state is more stable than +3. So that is the main thing, that is due to inert effect. The point here, one more point we have to take up here. +5 state is stable phosphorus but act as oxidizing agent. So here what you understand here is +5 state is stable for phosphorus but act as oxidizing agent with nitrogen, arsenic and antimony. The point here is +5 is likely to get changed to +3. This is the point. Here if +5 oxidation number is changes to +3, what it takes place? It takes place oxidation or reduction? The answer for that is reduction. Yes, +5 changes to +3, it means reduction. Reduction means it will be acting as oxidizing agent. This concept is very, very important. Please clear it thoroughly. Okay, so next point is oxidation states. We have discussed a number of times. I think now we are clear with that. Negative means electronegative character is there, tendency to gain electron is there. Positive means electropositive character is there, tendency to lose electron is there. And down the group, +5 oxidation state stability is decreasing due to not perfect. And the last point we are going to discuss here is nitrogen undergo disproportionation reaction. What is the meaning for that? Please calculate the oxidation number of nitrogen in HNO2. If you calculate 2 into -2 -4, -4 plus 1 -3 and +3, nitrogen is having +3 oxidation state in HNO2. And similarly, here if you calculate -6, -5 plus 5, here it is +5, +3 changes to +5. Okay, similarly here -2 to +2, it means +3 changes to +5, oxidation takes place, and +3 changes to +2. Reduction takes place. If oxidation and reduction takes place simultaneously for the same molecule, then this reaction is known as disproportionation reaction. Okay, that is also known as self-oxidation and reduction, because +3 changes to +5, oxidation takes place, and +3 changes to +2, it means reduction takes place. Oxidation and reduction takes place for the same molecule. That type of reactions are known as disproportionation reaction. Next is Again, this is the calculation of oxidation number. H is plus 3 and nitrogen minus 3 here. Similarly, minus 2. You can calculate and practice all the oxidation number. So this is very important that you should calculate it and check whether that oxidation number calculation is correct or not. It will help you to improve your fundamentals in regard to calculation of oxidation number. So same way, you can here also check the oxidation number, calculate, like for example, one I can do for you, NO3 negative is there. So 3 into 2 minus 6, minus 6 will go there, so it will become minus 6, 6 minus 1 is equal to 5. So this is nitrate ion. So nitrate ion, because 5 oxidation state is there, it is likely to get changed into plus 3. Decrease in oxidation means reduction and act as oxidizing agent. So please try to remember this concept. It's very important concept, how a substance is acting as oxidizing agent or reducing agent. So this again oxides. So here main point of understanding here is the nitrogen is showing the variable oxidation states, plus 1, plus 2, plus 3, plus 4, plus 5. Okay. Now here multiple bonding. Nitrogen, you know that it is highly inert. That is why it is used in the as an inert atmospheric gas during welding purposes, and moreover we are using in the chips packaging. Because not reacting. Why not reacting? Because stable. Why stable? Because of high bond association energy. So you can see from here, nitrogen has a very high bond energies. Okay. Why? Because of small atomic size, and moreover there is involves the bonding that is known as p-pi bonding. Nitrogen is having 3 bonds. That is p-pi bonding as compared to phosphorus is having single bond. So nitrogen is having p-pi bonding, 3 bonds are there, triple bond is there, and they are having high bond association energy. Okay, and phosphorus is having single bond, P single bond P, and it exists as P4 tetrahedral molecule. So similarly, we are going to take about the allotropy. Allotropy are having same chemical properties but different physical properties. Physical state, its appearance is different, color is different. Except bismuth, all other elements exhibit allotropy. Alpha and beta nitrogen is also there. White phosphorus, red phosphorus, black phosphorus are allotropes of phosphorus. Grey, yellow and black are allotropes of arsenic. Metallic yellow or alpha and explosive antimony are allotropes of arsenic. More detail about the phosphorus allotropes we will do in the phosphorus study. Next, it will come in few more topics coverage. After that, catenation, tendency of self-linking. One carbon is linked with 2, 3, 4, 5. That's carbon is showing a catenation, but not nitrogen. Why? The elements of group 15 shows much less tendency to catenation as compared to carbon. The reason is the bond energies. Lesser bond energy of nitrogen as compared to carbon. So that's the reason. Earlier we had discussed nitrogen highly inert, and that's all here there we have talked. But you need to understand that there were 3 bonds. Here it is single bond. So 3 bonds definitely will be having higher bond stability or higher bond energies. Okay. Nitrogen can combine with another nitrogen in hydrogen. Yes, of course, little catenation is there, but very few. Nitrogen, hydrogen. This is very important component for an explosive. 3 atoms in hydrojoic acid, that too also used in the initiators in explosive industries. Phosphorus exists as P4 cyclic tetrahedral molecule. That is a strained molecule, highly reactive because of the presence of one lone pair. Okay. Polymeric structure that exists with the red phosphorus. These P4 molecules are forming again bond with another P4 molecule, then P4 again. That long chain structure is formed, that cyclic structure, and it is highly stable as compared to white phosphorus, which is existing as P4, and it's a discrete molecule and it's a strained molecule having an angle of 90 degrees. Physical properties, all the elements of this group are polyatomic except nitrogen. All the elements shows allotropy and catenation, except exception is nitrogen diatomic, because nitrogen single bond is weak due to interelectronic repulsions. You know that whenever nitrogen is forming bond with another nitrogen, there will be lone pair, and small atomic size lone pair repulsions will lead to lesser bond energy for single bond. For triple bond I am not talking of. Metallic character increases down the group due to decrease in ionization energy decreases because atomic size is increasing. and nitrogen, phosphorus are non-metal. Arsenic, antimony are metalloids and this is metal. Now it's clear that arsenic, that was printing error only, it was metalloid. Now, anomalous behavior. Nitrogen is showing anomalous behavior. Like we can say that +5 oxidation state is less stable as compared to phosphorus. Why? So yes, it is there. Why not NH5 exist? This is the point. So the point here is why it is anomalous behavior. This is due to non-availability of d orbitals. And nitrogen is highly electronegatory as compared to phosphorus. Nitrogen having small atomic size as compared to phosphorus. This is an anomalous behavior due to absence of d orbital. Due to size very small, electronegatividity is very high. These all properties are related with anomalous behavior. And if you go down, last element bismuth, this is having anomalous behavior, different behavior. Why? Because of inert pair factor. Because this line is the down the metal character. Why? Because we have discussed already, ionization energy decreases down the zone. So okay, these two fundamentally you should keep in mind. Anomalous behavior, this I have covered in the video of last videos of that basic concepts of inorganic chemistry. Anomalous behavior in your book also it is there, and inert pair fact, that is the two more very important topics in this. So now these are the questions you should do yourself. Name all the elements of group 15 element with the symbols and electronic configuration. I think you can do. Why first member of group 15 element differ from the remaining members? That's the what anomalous behavior we have discussed just now. Dinitrogen is inert while phosphorus is reactive. We have to explain here the bond energy of triple bond is more, and as compared to P4 is a strained molecule, and it's a strained molecule is having one lone pair pulsions are there, angle is between 90 degree, which is a strained molecule and very reactive. You can read from the book, you will find in the coming little bit topic, there you will find more the relation in between these two questions. Diagonal relationship we have discussed already in the previous videos. Please take care of that. Explain with reason with suitable examples. And diagonal elements of period 3rd and 4th, that is having the similarity 2nd and 3rd period. And give reasons for low reactivity of nitrogen, that we have discussed already, because of high inert nature, and high why inert, because of bond dissociation energy is very high. Nitrogen is gas, phosphorus solid. So you know that nitrogen exists as discrete molecule, no tendency for catenation, but phosphorus it exists as P4, and moreover polymeric structure also. One P4 molecule is joined with another P4 molecule, another P4 molecule. This is association is taking place, but there is nitrogen is a discrete molecule, alone it is there. So thereby the molecular forces are weak in case of nitrogen, or multiple forces are there, and on phosphorus we are having covalent type of bonding. So thereby we can say that the solid nature is there, or we can say the forces, interaction of forces are more, melting point is more. Nitrogen diatomic, phosphorus is tetratomic. The same question came again. White phosphorus is highly reactive. White phosphorus is reactive with P4, exists as P4. Red phosphorus is existing as polymeric structure. You can just scroll the few pages of your book, you will find this answer. Why white phosphorus catches fire in air? Because of high reactivity. We have to explain the strained molecule of phosphorus with the diagram. Catenation, unlike phosphorus, shows little tendency of catenation. That depends on the let us say the bond length, bond strength. And allotropy and range in increasing order of +5 oxidation state. You know that +5 oxidation state will decrease down the group. Melting point of group 15 elements first increases from nitrogen to arsenic, and then decreases from decreases to bismuth, because this only we have explained already in the video. You can just do it. So my suggestion to you is the nitrogen, last question again. For nitrogen, phosphorus, arsenic form negative ion of the tie and 3 negative, whereas antimony bismuth form positive ion because of low ionization energy down the group. We have to explain properly the electronegative, electropositive factor, how it is coming. So if you have understood a little bit of all this, what I suggest you is you should read the book, try to cover up the assignments and the questions which we are given here now, and listen to once more if you are not able to clear that. So, and previous videos that in relation to the basic concept of inorganic chemistry, you should just go through once more to have a more conceptual understanding of inorganic chemistry. So let us repeat the thought. Be happy with what you have. Be excited about what you want. So thank you very much for your patient hearing. Thank you.